welcome to the practice problems video on trigonometric limits. Alright, so here's our squeeze theorem example. So what we're supposed to do is evaluate using the squeeze theorem. So we're given the limit as x goes to 0 of x squared times cosine 1 over x. So this thing given here, this is our f of x, okay? This is going to be our middle function, that's what we're going to try to make it be. So what we have to do is find a lower function, something that's always lower than this, and then an upper function as well, something that's always higher or above our given f of x. So what I'm going to do is start off by using our cosine here, okay? Cosine and sine are very useful functions because they always stay between or equal to or between negative 1 and 1, right, on our unit circle. So we can say that this is always going to be in between negative 1 and 1, all right? And now what we want to do is get our f of x in the middle here. So what we have to do is add that x squared in. So if we multiply everything here by an x squared, what we get is a negative x squared on the left is less than or equal to x squared times cosine 1 over x. So we see our f of x right here in the middle, right? So that's our f of x. And then lastly, we have our x squared. So we just found it. So here's our L of x. This is our lower one. That's always going to be less than or equal to our f of x, and x squared, a positive x squared, is our u of x. Okay? So now all we have to do is find the limit of our L of x as x approaches 0 and our u of x as x approaches 0. So what we're going to do is analyze what happens to the boundary functions, I'm going to call them. Okay, so as x goes to 0 of L of x, let's see what happens there. So this is going to be equal to the limit as x goes to 0 of negative x squared, right? So this is actually our negative x squared. That is continuous at x equals 0. So all we can do is, all we have to do is direct substitution. So that would be a negative 0 squared, so that's just going to be 0. Okay, so we know that the limit of the left function of the lower function is going to be 0. Okay, so keep that in mind. This is our lower one. This is our L of x. Okay, so now let's see what happens to our upper function, our u of x. So limit as x approaches 0 of u of x. Now that's going to read limit as x approaches 0 of x squared. And again, we see that this is continuous at 0. So we can just simply plug that in. So we get a 0 squared. So that just equals 0 as well. Okay, so this is great. That the lower and the upper functions meet at the same point, or they have the same limit as x goes to 0, right? So now what we can do is basically just conclude we're going to use the squeeze theorem here. So we're going to say that since negative x squared is less than or equal to x squared cosine 1 over x is less than or equal to positive x squared. So in other words, our L of x is less than or equal to f of x is less than or equal to u of x. That's just another way of writing it. So this was optional. I was just writing that for our reference. Okay, and since the limit as x approaches 0 of our L of x, of our negative x squared, is equal to the limit as x approaches 0 of our u of x, which was a positive x squared, and this equals 0, then by the squeeze theorem, then that means that limit as x goes to 0 of our f of x, of our x squared cosine 1 over x exists. So first of all, it exists, and it also, this limit, the same one, so I'll just rewrite it here, of x squared cosine 1 over x, it must also equal 0. Okay? Alright, so this is our conclusion. All of this is valid here as an answer. Alright? So this whole thing is an explanation of using the squeeze theorem. And also, I just want to say that, so pictorially, what's going on here is that our bottom function, or our lower function, is negative x squared. So that means it's based at the origin, and it's a downward pointing u. Right? So something like that. So this is our negative x squared. That's our L of x. And our upper function, so that would be u of x, is an upward pointing u. Upward facing, right? Upward opening. So that would be our u of x which is positive x squared. So that means whatever happens, f of x could be over here. This is our x squared times cosine 1 over x. But basically, when x is approaching 0, the limits have to approach 0 as well. Okay, so it has to squeeze in there. So this squiggly thing that I just drew is our f of x. Anything could go on, except for as x approaches 0, it must be squeezed in there. Okay? Alright, so now on to the next example.
We are fine. Just tell